So lesson 2, we're going to continue focusing on transversals and parallel lines and the equations that are formed in their intersections. So we're just going to go ahead and jump into some examples. So line S and T are parallel. So S and T, we are told that they are parallel. Lines M and N are transversals. Okay, so if the measure of angle 4 is 72 degrees, so if this angle right here is 72 degrees, then the measure of angle 10, would have to be whatever 180 minus 72 is, and that is 108. So the measure of angle 10 is 108 degrees, and the reason why we know that is because angle 4 and angle 10 are same side interior angles. They are supplementary. So angle 4 is 72, angle 10 is 108. All right, so the measure of angle 9 is this angle, and you can look at this from a couple of perspectives. If the measure of angle 4 is 72, the measure of angle 9 is also 72. That comparing that to angle 4 and angle 9 are vertical angles. And then for the measure of angle 3, for the measure of angle 3, that measure is here. So that particular measure would be 108 degrees since angle 4 is 72. So there's lots of, there's several reasons you could always state. All right, so let's move over to the measure of angle 8. So here the measure of angle 8 is 125 degrees. Then the measure of angle 16 is also 125 degrees because they are corresponding angles. They are corresponding angles. They are in the same position, so they are congruent and they're corresponding. Angle 13, the measure of angle 13, since 16 is 125 degrees, then angle 13 will also be 125 degrees because 13 and 16 are vertical. You could also say that angle 8 and angle 13 are alternate interior angles, so angle 13 is 125 as well. Then measure of angle 14, if the measure of angle 13 is 125, then the measure of angle 14 would have to be 55 because angle 13 and angle 14 form a linear pair, and linear pairs are supplementary, and so angle 13 and angle 14 have to equal 180 when added together. Okay, so now moving on to our next section. Again, we're going to be remembering and using our relationships between angles that are formed by parallel lines and a transversal to find angle measures. So here we're told that lines J and K are parallel, and I want us to find the measure of each angle below. Okay, well, this one is kind of, well, if you want to, we could say that because this angle 75 that measures 75 and this angle that measures 3 times x degrees are vertical, we know that 3x equals 75 degrees because vertical angles are congruent. Now, honestly, we know that because the angle that's labeled 3x is vertical to the angle that's measured 75, we know the angle measure here is 75 degrees. And of course, we can just follow through with the other relationships about this angle being 75 degrees because these are alternate interior, and this angle right here would be 75 degrees also. So then we can finish this out. This angle measure here, since that so does not make sense. This is not labeled very well because visually this angle cannot be 75 degrees. It's bigger than 90 degrees. Okay, well, regardless, I'm going to go ahead and finish this out as though this were a realistic drawing. So this angle would be 105 because this angle and 75 degree angle are a linear pair, which add up to be 180. So if this angle is 105, this angle is 105, this angle is 105, and this angle will be 105 degrees. So not real happy with that particular drawing and really didn't catch it until now. So let's see what happens with this. I want us to find all the measures here, and again, lines J and K are parallel, and we know that this angle measures 3x plus 10 degrees. We know that this angle measures 5x minus 10 degrees. So in order for us to figure out what the angle measures are, we've got to be able to, if we know what x is, then we can figure out what this angle measure is. So how do I go about doing that? Well, these two angles that are labeled are alternate interior angles, and alternate interior angles are congruent. So what that means is that 3x plus 10 equals 5x minus 10, and all I have to do to from here is solve this for x, get our value for x, and then we'll know what the measure of these angles are. So I'm going to subtract 3 from both sides, or actually subtract 3x. I'm left with 10 equals 2x minus 10. I'm going to add 10 to both sides, and that gives me 20 equals 2x, so x has to equal 10. So if x is 10, then 3 times 10 is 30. Add 10 and we get 40. So this angle measure is 40 degrees. Well, if these two angles are congruent, do I really need to substitute 10? I know that these two are going to be the same, but just for the sake of comparing this, 5 times 10 is 50, and when you subtract 10 from 50, you get 40. So these two angles are 40. The vertical angles would also be 40. So these two are 40, and this angle is 40. Then this measure, if this angle is 40, this has to be 140. This would also have to be 140. And these two angles here would have to be 140. Okay? So, all right, so let's measure, okay, so let's find the measures of these angles. So the angles that are labeled here, this is an exterior angle and this is an exterior angle, and they are on alternate sides of the transversal. So these are alternate exterior angles, and alternate exterior angles are congruent. So I can say that x plus 10 equals 4x minus 20. So solve this for x. We can find x, then we can find the measure of the angles. So I'm going to subtract x from both sides, and I get 10 equals 3x minus 20. I will add 20 to both sides. That gives me 30 equals 3x, and x equals 10. All right, so if x equals 10, then the measure of this angle is 20 degrees, which means this is 20 degrees, and this would be 20 degrees. This angle would be 20 degrees, and then this angle would be 160. This would be 160, 160, and 160. Okay, so I think we've got the hang of that. I'm going to skip over that example. But now let's talk about what we have here. Okay, the last set of examples says use the diagram below to answer the following questions. This question says if the measure of angle 4 is 95. So if the measure of angle 4 is 95 degrees, then the measure of angle 2 is what? Well, the measure of angle 2, what's the relationship between angle 2 and angle 4? These two angles are formed by two intersecting lines, so these two angles are vertical. So since they are vertical, this would have to be a 95-degree angle as well. Okay? And then finally, on the last example, now here, I'm going to go ahead and caution you, you have to be careful. This particular scenario says, if the measure of angle 4 is 95, can you conclude that the measure of angle 6 is also 85 degrees? So when you're looking at these two angles, can we conclude that angle 6 is 85 degrees? Well, let's talk about this a minute. If the measure of angle 6 is 85, then 95 plus 85 is going to equal 180. So if these angles are same side interior, then they are supplementary, and yes, angle 6 would be 85 degrees. But you have to be careful. This relationship, this alternate, the same side interior angles, that relationship is only true for parallel lines that have been cut by a transversal. There is nothing that says that this line and this line are parallel. You cannot assume that they are parallel. So the answer would be no, we cannot conclude that the measure of angle 6 equals 85 degrees because there are no parallel lines. So we don't have any parallel lines in this figure, so we cannot say that the measure of angle 85, the measure of angle 6 is 85 degrees. Okay, so that concludes this lesson.